Here's your pre-calc lecture for 9.1.4. It's part 2, and I'm looking at 9-71. If you watched part 1, we just solved the system of equations by finding the inverse of a 2 by 2 and multiplying both sides of the equal sign by the inverse. If it's not a 2 by 2, you're going to have to use a calculator, like to find the inverse of a 3 by 3. You can't do that little switcheroo thing. So I'm going to show you in this video how to use a calculator to find the inverse. So what you would do if you had a system of equations with 3 unknowns, now you have x's, y's, and z's. And when you make your coefficient matrix, you're just going to use the coefficients. So see where the numbers come from: 9, -3, and 1. They just come from the coefficients. This one will be 1, 1, 1, right? And then you're going to multiply it by x, y, and z, and you'll see if you did that multiplication, you would get this back again. These just go in a column matrix. So to solve this system of equations, you want to multiply both sides by the inverse of this matrix here, and then that's going to give you x, y, and z. So the inverse of this matrix is not pretty. So I wrote all this down. Basically, it's what I need to, like, if I multiply the left-hand side by the inverse, I'm going to get the identity matrix, which will cancel this out, and I'll get x, y, z. And then I multiply the right-hand side also, because you can't, whatever you do to one side of the equal sign, you have to do to the other side. So I'm going to multiply. I left it blank because the numbers are so ugly. But this is going to be the inverse matrix of that, and I'll show you how I'm doing it. I'm just using my phone. So what did I do? I went to Google and I said, Desmos matrix calculator. I just spoke that into my Google, and it gave me this beta version. Now you can use like a TI-83 if you know how, but this beta version, it's probably a little easier to use it on a computer, but it works just fine on my phone. So I created, whoops, oh, I killed it, so now I'll have to show you. Oh wait, no, it'll come back probably. There, it came back. So what you do is you push new matrix, and you tell it how many rows and columns you want. And like, so I had a 3 by 3, and see how it just lets me type in all the numbers. So the first thing I did is I just pushed new matrix, and I put my matrix in. That's the same matrix that I have here on the paper. Okay, and then to get my second matrix in, or to get the inverse, I had to click away from that matrix. So I just clicked, you click somewhere else on your screen, and you can put the second matrix in, and then then I clicked up above after I typed the second, like I pushed new matrix again, and you can like get a new matrix. I wanted 3 rows and 1 column like that. So it'll let you do as many as you want. But I didn't want to waste time on my video typing all the numbers in. So there's A and B. And then I pushed A inverse. So you have to click somewhere else, though. I clicked A. Well, oops. A inverse times B. I clicked the A, and then I clicked the A inverse, and then I clicked the times button, and then I clicked B, and it gave me the answer right away like that. So I want you to try this using your phone, or try to figure out how you can enter some matrices into a calculator, and see if you can get the right answer. You can check your answer because, well, Oh, wait, did I check? Is that right? Ah, I got 1, 3, and -7 for my answer. Is that right? Yes, that's right. I can check the answer. So if you try, this is 9-71. If you just go and take some time and try to see if you can enter these in using Desmos or whatever calculator of your choice. That's how you can solve a system of equations. So basically, see, look, here's a 4x4 right here. All I have to do is like enter the coefficient matrix here, and then push A inverse times B. I have to enter these numbers for the B matrix, and I would get the answers. So try those on your phone, and then when we have our Zoom meeting later today, you can ask questions, or you can just email me some questions that you might have. I also, in this video, since I have time, I wanted to go through problem 9-73. It says to calculate this matrix by hand and then with a calculator. Well, to calculate it by hand, to calculate the inverse by hand, I remember that I have to go 1 over the determinant times, remember we do that switcheroo where we go, this would be -2, -9, this would be -6, -3. So I need to find out the determinant, and when I do that, something interesting happens. -9 times -2 is 18, minus 6 times 3, that's also 18. I get 0, and if I multiply everything by 1 over 0, well, first of all, we don't want to divide by 0 in the first place, so we say that this matrix is not invertible, and if you stick in the calculator, it'll probably give you some kind of error message. So since the determinant is 0, you can't get an inverse matrix. It does not exist. Okay. So, and if you solved it by hand, if you tried to solve it by hand, you'd get no solution. Okay, so how are your answers related? If the inverse of a matrix does not exist, then the related system has no solution. So just remember that if you're when you're trying to solve systems of equations, just like in the olden days, back, in integrated 3 or whatever, sometimes the lines are parallel and you have no solution. So if you're trying to solve it with matrices, then you'll know that there's no solution, or it says sometimes there might be infinite solutions. You'll know that when you try to get the inverse and your determinant is 1 over 0. So I just wanted you to be aware of that. And then I think I might make another video about partial fraction decomposition, or I might direct you to a video that somebody else made. I'm not sure yet about that, but we might have to revisit partial fraction decomposition, so we'll talk about that one in a different video.